Oh, okay, looks like we're good to go. Thank you everybody for joining us this morning for this workshop virtual meeting on coastal bluff erosion. We're really excited to see such a great turnout from across the state. We're going to run this workshop from about now until 11:30, and we'll go ahead and get started. So we're going to quickly go through introductions. My name is Kathleen Fallon. I am the Coastal Processes and Hazard Specialist located on Long Island. I work out of Stony Brook University. Roy, if you would like to introduce yourself.
Hello, everybody. All 66 plus of you that are joined on. This is a really great turnout. My name is Roy Widrig. I am the Great Lakes Coastal Processes and Hazard Specialist for New York in the Great Lakes region, and I am located at Oswego State. Unfortunately, I haven't been there since March 13th, so I'm currently working out of Van Buren, New York.
Thanks, Roy. And Ali, if you could introduce yourself.
Good morning, everybody. My name is Ali Farhadzadeh. I'm a faculty of Civil Engineering and School of Marine Sciences. My expertise is more coastal and ocean engineering.
Thanks, Ali.
Hi. I'm Henry Bokinevich. I'm Professor of Oceanography here at the School of Marine and Atmospheric Sciences at the Stony Brook. I've been working on these kinds of issues mostly around Long Island, but also in the Great Lakes for longer than I like to imagine.
Thanks, Henry. And just a quick agenda, we're going to spend a couple of minutes doing a quick welcome led by Roy and myself. Then Henry's going to take it away with going through the geology, an introduction to the geology of coastal bluffs. And then Ali will take it from there and present the proposed research that he is planning to do over the next 2 years. And then we're going to end it with a discussion and question and answer session where we'd love to hear your guys' feedback and also your experiences working on the bluffs on Long Island and in the Great Lakes. So just before we get started, a couple of housekeeping. This webinar is being recorded. We are going to plan to distribute this recording via email after the workshop, and we will also post it on New York Sea Grant's website. The purpose of this meeting really is for you guys to be asking questions and providing feedback. We really want to hear from our local communities and stakeholders. So please feel free to type questions as they come up into the chat box. Roy and myself will be monitoring those. And of course, if anything pops up afterwards, feel free to send any of us a quick email. So just very quickly, a quick introduction to Long Island and the bluff erosion that we have here. It is quite an issue. It's something that we discuss quite often here on the North Shore and out in Montauk and East Hampton. And you can see from this picture, it becomes such an issue because we have quite a lot of communities that live on top of these bluffs. And as these bluffs erode naturally, we deal with issues to our infrastructure and our communities. So as I mentioned, Long Island is characterized by bluffs on the North Shore and in Montauk, and both of them are currently eroding at various rates. Along the North Shore, our bluff erosion tends to be episodic and happens in various rates, usually related to storm events, whereas out in Montauk, where we have continuous wave action, the bluff erosion is a lot more continuous and going at different rates. So there are things that we have done in order to prevent and mitigate bluff erosion. These two images, you can see the plantings and terracing that has been done. These are more natural nature-based features in the first picture I showed you, saw a bluff bulkhead at the toe of the bluff. So there's also more gray infrastructure options. However, we see here that even though you can put up measures to mitigate the erosion, if your neighboring properties are not protected, you might still wind up with issues. So bluff erosion and mitigation measures really need to kind of be a continuous option. And then I'm gonna leave that there, and I'm going to let Roy take it over.
Sorry, I had to unmute there. Thank you, Kathleen. Can everyone see? Well, that's what we're trying to avoid. So can everybody see that?
Yes, Roy, you're good.
So in the Great Lakes, we have really similar issues to what you have down in Long Island. Unfortunately, it's not as predictable as the tides would make it out to be. So we have bluffs in pretty much every Great Lakes county to an extent. They're not the same bluffs in every county, and they tend to vary especially on the eastern shore of Lake Ontario, or the eroding dunes along, southern Jefferson County and Oswego County, Sandy Island Dune Complex, that are where we're seeing the most bluff erosion there right now. However, on the southern shore, we have significant truncated drumlins left over from the last glacial era in New York State, and we kind of see the alternating drumlin wetland complex throughout the area. However, on Lake Erie, it's completely different. We see more shale cliffs and shale cliffs with the unconsolidated glacial material on top of them. Up until in my tenure at Sea Grant, we didn't see a whole lot of erosion events until Halloween of last year, which led us to believe that, this is a lot more storm influence on Lake Erie than it is on Lake Ontario. It's a little bit more gradual, but there are still severe events on Lake Ontario as well. Part of the reason we really wanted to push bluff research in this state is that in recent high water years on Lake Ontario, we've been getting more and more reports of erosion. These are, people calling our offices and saying, what do I do? And there's an influx of state funding that was brought up in 2019 due to the 2017 to early 2019 flooding as well. So I started this virtual site visit plan, and I noticed a lot of these reports were coming from the bluffed areas on the lake, especially Oswego, Cayuga, Wayne, Niagara, and Orleans County. And just recently, we've started getting more reports from Lake Erie because the lake levels just aren't going down to the point where people can, do a lot of work on their properties.
Hey, Roy, your slides are in that other view. If you could switch to presenter view or make them bigger.
How's that?
Perfect, thank you.
Okay, sorry about that, folks. So where we're seeing some of the most rapid erosion right now is in the Wayne County, Cayuga County area. This shot is right near Port Bay, where again we have a truncated drumlin, which has led to really rapid erosion. And Henry and Ali will get more into the mechanics of this later on. But what we see is wave erosion at the toe, causing a lot of slumping on the bluffs. Most of the time, it's kind of an interaction between some more harder to erode glacial till, but with a lot of outwash material. Outwash is kind of like coarse stone, coarse gravel, more like river type sediments. And when you get this mix of the materials making up the bluffs, it makes them very easy to erode. We also had incredible climatological drivers to the 2017 and 2019 erosion, which led to much higher lake levels, which meant that the wave action was really crushing the toe of these slopes more frequently than before. And what we struggle with a lot of times in the Great Lakes is that we have such an array of different methods of shoreline protection, and just this kind of mishmash piecemeal method where we get stone riprap that goes in that may or may not be well installed, right in between, you know, in the case of this photo right here, we see a lot of stone installed to the north. There's stone installed to the south, and the area in between is a nature preserve where they're not going to have the money to install this, but they just happen to be the eroding bluff in the middle. And a little bit off frame here is a road that leads to all of these secluded properties. There's only one way in, one way out, so it creates an emergency management issue as well in some places. And more on just the total mashup of shoreline protection methods we see. There's been all kinds of stuff going in on this lake since, you know, way back into the 1920s when a lot of this work started. We see a lot of it during calm periods where people do a little bit of work, and then when lake levels come up, it's not quite adequate. So a lot of times around these bluff areas, we're just kind of at a loss for what to do that's going to be more resilient for the longer stretches of shoreline instead of just one property itself. Very briefly, we'll put these in the chat box. Hopefully you guys will be able to submit your bluff erosion to us. We have two separate links here, and again, I'll put these in the chat box when I'm done. One for Long Island and one for Great Lakes. Thank you to those of you who have already filled this out. And just to give you an idea of what this is going to look like, it's a survey 123 form. Very simple. You just submit your name, contact method, whatever municipality you're in. You would be able to move this cursor around to put it exactly where you want it to be. So I'll just look up here. And then you're able to describe your erosion issues. What we like to know about is the history of what's gone on in your areas, so we can get a better idea of what's happened in the past and help us plan for the future. And you can also submit photos to that, which is really helpful for us, especially now when it's a lot harder for us to get out into the communities to consult with you as well. And if you want to, these are going to go to Kathleen and myself. So if you would like to request like a site visit or a virtual site visit, this would be a good first step to do so. And that's all I have. So now we are on to Henry.
All right, great. Let me see. I got the share screen here. Share.
And just while Henry's pulling up his slides, the two links for the surveys for the Long Island and Great Lakes are now in the chat box.
Well, I suspect that most of you had firsthand experience in bluff erosion and all of these issues in the past, one way or another. But I would like to make a few introductory remarks about research into bluff erosion and in anticipation of what Ali will talk about, the things that we're working on now. And of course, the ultimate goal of all of this work is to somehow anticipate erosion and to identify the particular causes and ways that might be mitigated. We're just kind of we're always in sort of a first step in doing these things. I'm sure you know many people who have seen bluff erosion or suffered from it. There tends to be a tendency to think about it in one of two ways. Either that it's the same all over the place. My neighbor has the same sort of erosion as I do, or erosion in the Great Lakes is pretty much the same as erosion in Long Island Sound. Or, on the other hand, there's a tendency to think that every place is unique. The factors that cause erosion and the rates of erosion are so variable that it's easy to think that these places are special somehow. And that would make it hard, of course, to anticipate or predict erosion anywhere. Part of the reason for the surveys is to try to assemble information on both of these viewpoints. What are areas that are the same? What are areas that are different, so we can pinpoint those differences? So the shorelines that we're talking about, these high, steep, unconsolidated loose bluffs, are really a fairly rare sort of shoreline around the world. Of course, they exist on the Long Island shore and around the Great Lakes, but they're found in Cape Cod and the outer islands, and then all the way over on the west coast in the Northwest Pacific. But as you go south of us from here or north of us, these kinds of features are rare. They're not found very prevalently. And this is one of the reasons why research into bluff erosion and the state of our knowledge of bluff erosion for prediction purposes is also a little bit rare. There's much more research that's been done on beach erosion than on bluffs. So we're in part trying to make some progress in that arena to improve our capacity to understand how this is working and why this is working. The bluffs on the Great Lakes and around Long Island do look an awfully lot alike. And it's tempting to say that they're all the same. They're all pretty much similar. And it's even more tempting when the impacts are identical. You see this in the Great Lakes and you see this on Long Island. It doesn't take much imagination to relate the two in terms of the processes. On the other hand, you also see things like this. These are the Chimley Bluffs in Lake Ontario, something that's very different and makes you think, well, there's something unique going on here. Part of this is a problem in compositional material that forms the bluffs. On Long Island, many of the bluffs have a foundation of Cretaceous sand and gravel, very old material that has then been modified by the last glaciation. Around the Great Lakes, as Roy was saying, much of the loose material of the bluffs is composed entirely of glacial till. They're more recent material, different composition, and leads to a different behavior. When Eileen talks about the research, these compositional differences are one of the elements that we're trying to incorporate into our understanding of bluff erosion. Regardless, though, the problem is this very much the same. It can be viewed as the same. All of these sections of shoreline are subject to the CHA, the Coastal Erosion Hazard Area Line, in recognition by the state that these are, in fact, hazardous locations and things that the state has some jurisdiction in regulating. So there's this similarity that extends across areas both in the Great Lakes and on the Long Island. The culprits are pretty much the same, though. The shorelines might be a rare type globally, they might be different locally, but they're subject to similar stresses. Around Long Island on the ocean coast, we have storm surges. The nor'easter of '92 is shown here, where the water levels in Long Island Sound and on the ocean were rising by as much as over 1.5 meters during those brief periods when the nor'easter or hurricanes had come through. On the Great Lakes, Ali has done some work on sation, where the storms on the Great Lakes may not drive in ocean water like it does Long Island Sound, but it tilts the water level and can raise the water several meters on the coastline. In both cases, this drowns the beach and allows the bluffs to be attacked by waves. The other similar feature are water level changes. In the lower diagram is a record of from the tide gauge at the battery for over 100 years, showing that the sea level, the mean level of the water, has been rising steadily, sea level rise that we're all familiar with. And also there have been these spikes in water level. You see the curve is not smooth, but goes up and down over several meters in the course of the rise in sea level. So this long-term change we have to contend with. In the Great Lakes, as Roy pointed out, there's similar sorts of changes that go on because of the water level changes due to precipitation and the input and output of water level into the different lakes. So that changes in lake level produce these long-term stresses on the system, which again can drown the beach, allow the waves to progress directly over the beach and undermine the bluffs. Ali will talk more about the details of this process as we go further. But waves are the most likely suspects. We can see this happening. If people who live along the shore can see this during a storm, have a good experience in how dangerous that wave attack can be. And it's certainly one of the obvious and primary driver of this. But the waves have kind of a silent partner, something that aids and abets them in the things that we don't really recognize in an invisible factor due to groundwater or the subterranean water content of the bluff material. So on Long Island and elsewhere, the groundwater levels can actually undermine, sap the bluffs, weakening the bluffs even without the waves. And the water content in the soil makes a difference as to how resilient the soil is or how resistant the soil is to erosion and large-scale collapse. So another element of the research project that we're pursuing is to look at the influence of water as well as composition on the susceptibility of these coastal features to erosion. So with that little bit of an introduction, I'm going to turn it over to Ali, who will give more details on what we're planning, what we've recently done, what we're planning to do in this year, in this future, near future, and hopefully we can get some input as to how this relates to the individual problems, individual issues at sites around both the Great Lakes and Long Island, as well as the common issues that plague these communities. So we're going to stop, I'm going to stop there, and Ali, it's up to you. Let's see, we stop this. I stop the share, and...
Thank you, Henry. All right, let me share my screen. Is that good now? You can see. All right, so thank you, Henry. This is basically the project Henry and I proposed to New York Sea grant, and it was funded. I'm going to basically giving a little bit of presentation on what we have done. We have been trying to understand the bluffs over the past 2 years, and it kind of gave us some fundamental information about some of the important processes in bluff erosion. Then what we are planning to do in the next 2 years as part of this funded project. So I would like to first of all thank the Sea Grant for funding us on this project. I am living on Long Island, but also I have some experience with Great Lakes coastal flooding project. I was a technical lead on one of the FEMA's flood maps production project, working with the Army Corps, and I was working in industry, but we were a FEMA contractor working on those projects. It was 2011, 12. So my focus was more on Lake Erie, but I've done some work on Lake Ontario. So I'm a little familiar with the coastal environment of the Great Lakes. Let me move on to the next slide. All right, so I'm going to give a little bit of introduction, and then what our goal was as part of this research, some of the results, and some of the conclusion we came up with, and the future work, which is going to be very brief, but I'll try to be as detailed as possible within the scope of this work. So the motivation is basically that there are a lot of bluffs shoreline along the in the world, but also in the U.S. In Great Lakes, we have like 12% of the shoreline. You can see this table is bluff. On West Coast, basically, we have more. We have 72% in California and 58% in Oregon. So it's a big chunk of shoreline made of bluffs. And the problem is, that once you lose the land with the bluff erosion, you cannot gain it, unlike sandy beaches, when you can do beach erosion, beach nourishment, and those kind of projects to kind of recover. But this is not going to happen when you have a bluff erosion. And they pose risks. It's a kind of multi-hazard risk. You have a building and infrastructure could fall down. And also there was a news actually last year that people were enjoying the beach in California, and Bluff failed, and they were killed. So it has some hazard and risk to the safety of people as well. So it's a big challenge. And again, we are trying to understand, at least in part, what causes bluff erosion and how we can control it. We're not going to be able to stop it, but at least manage it. A lot of reports out there for the erosion of bluffs in Long Island and in Great Lakes. You see some of the statistics here. I'm not going to go into that. This is a picture of Montauk Lighthouse. In 1796, the lighthouse was 297 feet from the edge of the bluff. In 1967, it was 55 feet, and probably now it's less. But there's some protection work going on in that area. I suppose it's going to reduce at least the erosion rate to some degree. A video I found on YouTube, and I'm going to share it with you.
Homes are breathtaking, a 100-foot straight drop to Long Island Sound. But the incline is getting more precarious. Peter Scott loses 2 feet of backyard to erosion every year.
We should be allowed to build these walls.
With DEC and village permission, he had this massive terraced wall built, footed with huge boulders to stave off erosion, protect his home and property.
We should be able to protect it. We're not taking away from anybody. There's no way they can say that the beach is being destroyed by what we're doing.
But down the block, this wall may have to come down. The owner did not get village approval first.
It was an audacious act of unlawfulness.
The violation adding fuel to an already heated issue. Some experts argue seawalls to shore up private homes, bluffs, are thinning out public beaches downstream by interrupting the natural flow of sand. Nancy Featherston claims seawalls are making her community's private beach disappear.
You will destroy the beaches. You're stopping the nourishment of sand that created them.
The problem's not just here in Nissaquag. Across Suffolk County's North Shore, homes are in danger and beaches are being swallowed by dramatic erosion. A statewide master plan is not always implemented uniformly. As this home teeters on the cliffs, the owner, who declined comment, may now have to tear down this 6-figure seawall. A Bluff Road neighbor's seawall is under construction.
We're preserving the beach. We're preserving the coastline. If you go to Connecticut, it's all rock walls all along the coast to protect it.
2.5-ton boulders may have to be moved or even removed. The village hasn't ruled yet. In Nissaquag, Long Island, Carolyn Gussoff, CBS 2 News.
Now an attorney for the...
All right, so it looks like everybody's right, so we don't really know. But I think there are some truth to everybody's statement. The bluffs, supply sediment to the beach, but also, there are some hazard to the infrastructure that they need to, worry about. So that's understandable. This is a picture of, there are videos like that for Great Lakes Bluff as well. Great Lakes Bluff, there's a big difference between what we see in terms of bluff materials on Long Island and Great Lakes. So we're trying to, that's part of the work that we are doing, is to look into the composition, the effect of composition of soil and its property on the rate of erosion. So on Long Island, most of the bluffs are mainly sandy with some silt and clay, typically around 70–80% sand, 20–30% fine grain material. On Great Lakes, we have mostly till bluffs and with a bit of sand. So it's a basic two ends of the spectrum in terms of composition. It's on Long Island versus Great Lakes. The forcing mechanism, as Henry also mentioned, is different. We have here the South Shore is different from the North Shore of Long Island, but in Great Lakes, sage, freeze, and thaw, and precipitation, even ice impact are the main erosion driver. The sea level or the lake level is being managed to some extent, but again, as Henry mentioned, we have done some work on sage, and we see that, you know, if the trend of warm winter continues with less ice coverage on, for instance, Lake Erie, we expect more saging and more erosion in the future. So that's a paper we just got accepted, and it's going to be published in Journal of Coastal Research soon on the effect of sage on the erosion. This is I'm showing some of the ice coverage for Lake Erie and the Great Lakes. So the vertical axis shows the percentage of ice coverage on the Lake Erie, the top panel I'm talking about, and the horizontal axis is the year. So you see that, you know, so when this curve goes down, it drops. That means the ice coverage, the area of the ice on the lake was low. So as low as about 10–20%, and as high as typically historically around 80–90%. You see that, you know, I put that curve around those dots. That means we have more warm winters over the past 10 or 20 years, 15 years, pretty much. We get warm winters more frequently now than in the past. So that's going to, you know, exacerbate the sage effect and erosion in the future. So the bluff erosion is a very complex process, as Henry rightfully mentioned. We have a bunch of processes all together contribute to the bluff erosion. We can categorize them in two main categories, and land-based versus sea-based. Sea-based basically is the wave water level, which is going to lead to wave impact, foreshore erosion, and so on. And then this is also in tandem with land-based processes, which are rainfall, seepage, basically whatever mechanism you can think of that weakens the soil and leads to the, you know, soil losing its resistance and its failure eventually. So the picture, the cartoon at the bottom shows, you know, how the wave leads to toe erosion here. And that's pretty much happens when the wave hit the structure, the bluff, and can run up this much, for instance, and you have this notch forming here, and this basically undermines the bluff stability and it just falls. Obviously, if you have seepage and runoff and so on, you're going to be dealing with the much less strong soil, and the failure would happen much easier than if the soil is strong. So our goal was to try to understand the recession rate, or characterize the recession of the sloping beach and bluffs under wave and surge attack. And our goal was to look into these three components: fine content, that means the amount of, or the composition of the soil, how much fine material, how much coarse material we have in the soil. What is the relative density of the role of relative density, the looser or less compact the soil compared to the denser soil? And what is the role of water content? You know, obviously, if you have more water in the soil, more pore pressure, and less resistance. But our study in the past was focused on the optimum water content and on the dry side of the optimum water content. We're going to continue working on this with the different rate of water content in the next 2 years. To do that, we went to Montauk with my student. We collected sediment. We had permit from the parks, thanks to them. But people still came up to us and asking, why are you, destroying the bluffs? And we said, no, we are not destroying it. We are trying to understand why erosion happens here. So it was a very, it was kind of impressive. It's, it shows the responsible citizens are also concerned, or maybe even more concerned as us about the bluff erosion and the health of or healthiness of the shoreline and the beaches. We took samples, a few tons. We rented the U-Haul. We collected sand in bags and brought them to the lab. And we tried to characterize their soil mechanical properties. We did sieve analyses, all those sort of geotechnical tests that you can think of to get a sense of what their mechanical or the resistance indices are. So this table basically shows the range of or the variation of different parameters, even within that small section of the bluff. So we can imagine, how wide these values could be if you, travel along the bluff on Long Island, or even you compare Long Island with the Great Lakes. So these ranges could be much wider, and that's going to, add up to the complexity of the bluff recession processes. So these are the tests we did. And then what we did is, within these range, we tried to come up with some sort of controlled experiments with different fine contents, 0, 5. We basically reconstituted the soil, the original soil, into 5 different soil compositions, 0, 5, 10, 15, and 20% fine material. The rest was basically sand. And then we looked at 2 different water contents, 7% and the optimum water content, which was different for these 5 different soil compositions. And then we look at 2 different relative density, one on the looser side, one on the denser side, 39% relative density versus 68. So basically, this is an indicator of the last 2, the water content and the relative density, kind of represent the packing and how dense, or maybe you can think of consolidation to some extent. They're not exactly the same, but they may be demonstrating similar behavior in terms of soil response to forcing. So these show the optimal water content test, the Proctor test that we did, for different soil, the dry density versus water content, and these peaks basically show the optimum water content. That means, the water content that results into the maximum packing of the soil. So, and this is the grain size distribution for these 5 samples, or that we reconstituted for testing. We did the triaxial test. We measured the shear strength. Basically, triaxial test gives you indices of how strong the soil is under shear forces. These curves are known as more column failure curves. And I'm not going to get into the technical part of it, but it gives you an indicator of their mechanical strength. So these are the properties of the 20 samples. Here is the first 10 sample, which were packed at the lower density with 0, 5, 10, 15, 20% fine material, and loose and dense. Oh, this is with the dry sample. The other one is the one with the packed at the optimum water content. So this basically summarizes the properties of different soil that we tested in the lab. Then we built this model, the Bluff model, in the lab in a small flume that we have. So these are the dimension of the bluff that you see here. It's small, but again, this was more of exploratory experiments to try to see how significant each soil indices are in terms of bluff erosion behavior. And then we did some image processing to get the erosion. So what we did is we created this bluff in the lab. We set the water level. With the paddle, we generated waves. And then we took videos of the bluff responses, erosion, and so on, and then we translated into beach profile or bluff profile evolution in time and spatial also analysis that we done. Then we raised the water level, try to mimic the sea level rise or the surge level impact on the bluff erosion. We ran the wave again for another 12, so each stage was 12 hours. 12 hours of the wave impacting the bluff at certain water level. Water level was risen another step, another 12 hours, and then third time, another 12 hours. 36 hours of wave impacting the bluff was done for each 20 bluff samples. So these are some processes, what we did to prepare the soil. I'm not going to go into the details of it. This is the molding that my student did. So we created this bluff like with layer by layer because we want to make sure that we have a homogeneous bluff properties, through the depths of the bluff or the height of the bluff. These are the wave properties we did. So we had different 3 water levels. Stage 1, 12 hours. The water level was this much. The wave height was this. And then you see all these characteristics of the wave and water level. And then the water level was risen another 1 centimeter, then 12 hours of these, and then another time and 12 hours of this. So this is a video of the kind of sample video of what we see in the lab. I'm going to show it a couple of times, but just look at this. So we have a notch formation, and then the wave tried to move the deposit offshore, and you see that these places you have a migrating sandbar going offshore. And obviously it adds to the behavior of the wave, because now wave breaks farther offshore because we have a shallower depth here, right? So I'm going to show it one more time. So you just look at these migrating sand, and now when, so what bluff does is, what bluff failure does is it temporarily protects the shoreline, and it kind of balances the sand and basically, calm down the sediment erosion processes for a while. And then after a while, so nothing happens once you reach some sort of equilibrium situation. So if I continue running this for another 40 hours, nothing is going to happen because it's an equilibrium situation. But once I raise the water level or I change the wave properties, again, another failure is going to happen. So it's a kind of episodic process. So it doesn't happen, and then all of a sudden you have a lot of sand supply to the beach. But again, the point is, if nothing happens on the land side in terms of sand or the bluff strength, the material strength, in terms of if you don't have a lot of precipitation or so on, and we only continue with the same type of wave and water level forcing, the bluff is not going to fail. But once there's a change, something triggers, like water level rises and then or wave increases in terms of height, then you're going to have bluff erosion and failure. So this is basically image processing we did. So we took picture from the side of what you just saw in the other video, and then we translated to this dash, the red line, like each profile. It was hard because the water was brown and it's sometimes confusing with the soil, but we came up with some techniques to eliminate those confusion, and we came up with the fine, nice beach profile. So this is again the process that I just discussed. Initially, you have a bluff like this. Everything is in equilibrium. Then you rise the water level. It starts creating a notch. And then this notch fails. And then the sediment is going to be migrated offshore. You have a new equilibrium beach profile now, and then nothing happens until you change something in terms of water level forcing or wave forcing, and then we have another cycle. So this cycle continues going on and on, depending on the change in the wave and the water level forcing. Some of the results you see here at different stage, we had different failure, but if I can summarize this is, once you go toward more of clay materials, or even denser material, the bluff erosion is going to be significantly reduced. And what we found is the composition is important, but more important than composition is the density of the soil. If you're, exposing a much denser soil to the same forcing as looser soil, even the looser soil has more clay content, the denser sandy soil is going to be more resistive in terms of erosion. So these are the profile of the bluff at the end of each stage. These, you can see these notch formation. These are more, we call them tensile failure, as opposed to this one, for instance, which is more of shear failure. So sandy soil with a looser density and less fine content demonstrate more of a shear failure. This bluff with more clay content or denser bluff in terms of material, they demonstrate more of tensile failure. So you have this cantilever type of failure happening in a denser or more, the soil with more fine content, typically. We did some numerical modeling of this to come up with the range of tension and where this weakness happens, and they also confirmed the model results. So we have the concentrated tension here, which is going to lead to the failure, and also we have the shear failure for the denser, and it kind of shows the distribution of tension, because it's important for relating the soil strength to the erosional behavior of the soil. Again, this lists the type of failure, shear versus tension versus for soil, and for loose and denser soil, which is in the next slide. Actually, this is more of a visual presentation of the table, the recession rate for different test cases. We came up with this relationship. This is probably more informative. The rate of recession, we found how it relates to this Greek letter psi is basically the amount of fine material in the soil, and the dr is the relative density, and omega is the water content. So different parameters play different role, but our model kind of looks pretty good in terms of comparison with the measurement. So that was, I think, kind of impressive. Some of the conclusion we have is erosion of beach and bluff with looser soil and fine content less than 10%. We had 2 bluff failure, but once we had dense soil and more fine content, we had only 1 failure. So again, more fine content, denser soil significantly reduces the chance of bluff failure. The bluff recession rate decreased as the fine content and density of the soil increased. That's what I just mentioned. The effect of fine material in reduction of recession was more pronounced. So yeah, so once we had a looser soil versus denser soil, the amount of fine content became more important when the density was low. But once the density of the sand was high, adding more fine content didn't change the behavior of the soil much. And for all cases, optimum water content, so once you have the water content that give you the more packing, we call it optimum water content, the recession is going to be significantly reduced compared to the bluff that is more dry. We're going to look at the wet bluff, like we have a huge precipitation, and have a very, runoff, a lot of runoff, which kind of takes the soil above in terms of water content, beyond the optimal water content. We're going to look at it in the next year or so. A beach and bluff profile reaches a very relatively equilibrium condition after a while, and nothing changes until you change the forcing mechanism. And then we had that empirical relationship. The future work, these are what we are trying to do. We are trying to look into a broader range of variables that I just discussed. And first, we are going to look into the erodibility of the soil and link it with the soil strength, material strength in terms of geotechnical properties. We're going to run some like a Shields type diagram for different soil of different properties and kind of come up with basically formulate the erodibility of the soil under different shear forcing. And then we're going to implement it into our process-based model we call Seashore. It's right now being used by FEMA flood maps, it's a model I worked on during my PhD studentship at the University of Delaware called Seashore. And we're going to try to add these formulas into the model in order to be able to be used for bluff erosion in different places. For doing the soil property and doing the erodibility analysis, we're going to look into different sites, Long Island and Great Lakes. We're going to take sample from different sites and do the analysis and try to look at both, again, type of soil and bluff. Again, that's pretty much what I just discussed. These are some of the publications we had, and we're still working on more publications, and hopefully with the new research in the next 2 years, we have more to present next time, but we're happy to answer any questions.
Great, thank you, Ali. That was really informative. We do have questions are starting to come in from David Clark. Wouldn't we expect coarser material to remain in nearshore longer, supporting an equilibrium beach profile, slowing toe erosion?
That's true, but the problem is, when you have, what we are trying to do here is we are looking at the cross-shore variation or erosion behavior only in the cross-shore direction. But in real life, you have also long-shore sediment transport. So those coarse material, I suppose you're talking about gravel type material, are going to be easily transported along shore, and they're not going to stay there forever. So that the process is not very, I think, site specific. It's more of a regional, general problem. So the variation in bluff, even if you're thinking of what I just discussed, I'm living on near the edge of the bluff where the clay content is high and the soil is pretty dense. That doesn't mean that that place is going to be safe. If let's say a mile away from you, the soil material is weaker and it's subject to more erosion, it's going to propagate in along-shore direction. So yes, to some extent, yes, but it's not going to be permanent. It's similar to what I showed in terms of the deposit after the failure. It temporarily protects that beach, but those materials are going to be transported along shore and they're not going to stay there. So it's a temporary protection, not permanent.
Thanks, Ali.
Sure.
Next question is, was there any consideration of homogeneity versus mixed media for the shoreline recession modeling?
Is it more of, I'm trying to understand the question, more of like a homogeneous versus heterogeneous soil behavior? Yes, yeah, that's a big problem. Yes, and even what we did was all homogeneous soil, but in real life, you have soils of different layers of the bluff. You have different soil and different properties. So once we understand the behavior of each individual material in terms of their erodibility, in the numerical model, we can prescribe those properties in different layers or different grid points in the model. And then you will be able to look at the holistic behavior of the heterogeneous bluff material. Yeah, that's an important point. Thank you.
Thanks, Ali. Moving to the next question from Emily. Based on your research, would it be beneficial to use fill with a higher soil density to protect infrastructure?
In terms of erodibility, yes. But again, it's not, I mean, if you're asking whether that kind of measure would protect a particular property, that's probably, the answer is probably yes, but temporarily, as I mentioned. But if it's more of, for instance, if you come up with more of like an irrigation system for a stretch of bluffs in order to reduce the water content or reduce the pore pressure and make the soil more compact, that would probably help reduce the erosion rate. But if it's only one person doing some mitigation of his or her own, that's probably not going to help in the long run.
Thank you. Ali, can you go back to the slides on erodibility indices?
Is it the indices? I'm not sure exactly which slide it is, but try to.
The question is, will this be in the form of a mapping product? If not, what are the potential applied results?
Our hope is to be able to develop this numerical model or advanced numerical model, because right now the model is not capable of predicting bluff erosion. It's designed or developed for sandy beaches and dunes and those kind of beach features. But if you're able to enhance the model toward this kind of applications, that could be used for practical purposes. I mean, again, Seashore, the model we are trying to develop or enhance, it's already being approved. It's funded by Army Corps. And when I was working for FEMA project, we used it to map the Great Lakes flooding and shore erosion. Obviously, we didn't include the bluff erosion. We treated it like sand dunes. But once you enhance the model to be able to predict the bluff erosion, you can apply it or improve those type of flood map production or other application, design application, pretty much. That's our hope.
Awesome. And then moving to the next question, to what extent will your research consider the extent to which neighboring properties are hardened, possibly altering the wave climate on the bluff you are modeling?
Yeah, we can do that. I mean, right now, the model has its that kind of capability that you could put a seawall and see how it impacts the neighboring property. But again, everything is, as of now, it's based on sand and sandy material. Yeah, that can be done. Yeah, you can harden the beach and look at the neighboring property. Right now, you can do it even without the bluff component. But if it's, if you add this, it could be applicable to bluff shoreline as well.
Thanks. Tom would like to know if the use of snow fence and vegetation, such as American beach grass, would be helpful at the toe to mitigate erosion.
Good question. Yeah, there are a lot of discussion about the living shoreline and so on. I'm not a believer in that, to be honest, not because I'm not in favor of environmental approaches, because those methods are not mature enough. And I'm an engineer, so I like to build things and like harden the beaches. But Henry may have a different opinion.
Well, in general, if you can build a dune at the toe of the bluff, that would certainly serve as a type of armoring or a type of protection. The question is whether there's enough sand available to be caught in the sand fencing or the vegetation. And the other issue is dunes themselves are susceptible to erosion, so that you need a fairly large volume of material in order to protect you against one big storm, and then you might have to replace it after the next. Now, that's not necessarily a disadvantage, but it is a consideration as to how you design this protection.
Thanks, Henry. Ali, going back down to the next question, can you speak to the role of nourishment?
just I think Henry just mentioned, if you, I mean, the bluff, you cannot nourish it. But if you're talking about the beach nourishment, yes. Once you, I mean, the waves are sand thirsty. That's what we call them. So they're thirsty to take the sand away from the beach. So if you feed them or provide them with the sand, they're not going to go after extra sand because there's equilibrium, as I mentioned. Once you establish that equilibrium, then you're going to be safe for a while. So the question is whether that kind of nourishment is compatible with the type of wave that you have, the type of beach material that you have, or it could add up to the problem rather than helping. So it's a very, I think, fine line in terms of designing a nourishment project or planning that would maintain that kind of balances. So yes, again, if you can establish the equilibrium to whatever extent that you can using other alternatives, it's going to reduce the risk of erosion of the beaches.
Thanks, Ali. Does bluff failure really help beach nourishment, and is it important for environmental reasons, as some claim? And do building bulkheads and seawalls really damage the beach and bluff?
Again, that was a kind of discussion in the video I showed, right? So everybody's right. I mean, if you, again, don't provide the sediment to the beach, they're going to be eroded. But that erosion is probably has a different source. It's not something local. So something happened up, updrift or downdrift that kind of changed the balance of beach erosion. I mean, could be sea level rise or change of precipitation. All those processes basically change the balance among different players, marine base or sea base versus land base. So now, yes, if you build the bulkhead, you're stopping providing the sediment to the beach, and it could, I mean, those I don't believe those bulkheads are going to be protecting the bluff forever. They're going to be also failing too. So it's, again, it's not that you are saving or doing something in advantage or disadvantage of the beaches by protecting your bluff. I think the problem has a different root. The cause of the erosion is not something related to, or to the protecting the shoreline or not protecting the shoreline. So it's not a local problem. It has a more, I think, deeper root. And I don't really know what the answer to that question would be. But my point, yeah. Someone is.
The bluffs do provide sediment to the beach. The real question is how much and where. We looked at the issue of the Montauk, erosion of the Montauk Bluff providing longshore sediment to Long Island. It turns out, even though it does provide sediment, it's a fairly minor component to the total amount that you need to maintain the longshore transport. In places on the Great Lakes and on the North Shore, where the shoreline is more compartmentalized, the local bluff erosion could be the principal supplier of sand to the beach, but it doesn't have to be. And I think you can answer the question generally saying, yes, it does supply sand, you don't want to cut it off. But the real issue is how much and where.
Yeah.
Can you afford to nourish 10% or to protect 10% of the bluff from erosion? Can you protect this entire bluff from erosion and still not impact the sediment budget? Those kinds of things are
right.
much more difficult.
Yeah, that's exactly the case. So that particular shoreline or protection of the shoreline may not really help the more chronic erosion problem of the beaches. They're having a deeper root. It's not just a local problem.
Thank you. Moving on, this wave impact in your wave tanks, Ali, appears to be perpendicular to the shoreline.
That's right.
A majority of wave impacts are angular to one degree or another.
Yeah.
Would that be a potential major driver of bluff base removal? And is there a range of wave angular impacts that produce greater erosive forcing?
Yes, well, I mean, in coastal engineering, we know that once the wave comes from a 45-degree angle, you have a much stronger alongshore current, which basically exacerbates the erosion. But this particular case, we actually look into the more extreme situation. It's a kind of heads-on impact. The wave comes and directly impacted toward the bluff. But in real life, you don't, or you often have waves coming obliquely. It's more with the angle. So you don't have that kind of high run-up, which appear to be the main driver of those notch formation. So if wave comes with an angle, obviously the run-up is going to be lower and the notch is going to be smaller. And also the wave velocity, the flow velocity that causes the erosion at the toe is going to be less. So, but again, you would have a longshore sediment transport and it could impact the neighboring or the downdrift bluffs as well. But yes, that's an important point to be considered.
Thanks, Ali. And Aaron would like to know what erosion control solutions will be revealed as the result of your research. Will these be solutions for individual parcels or only for regional large-scale projects?
I think, yeah, it's not about individual parcel solution. It's more of understanding the processes and implement those basic knowledge that we developed through this project into some sort of applicable or kind of practical tool, a numerical model, or some sort of empirical relationship that we could maybe use it to apply to anywhere, regardless of whether it's someone's property, Great Lakes, or wherever it is. Once you know the soil property, you could basically model it in the numerical model and run the model and see what the response of the shoreline would be. So, but again, what we are trying to do is we are looking two different sites, not particular location, the typical soil in Great Lakes shoreline and Long Island South and North Shore. And we try to characterize their property in terms of composition and mechanical strength, and then do some tests on those soil to get maybe a formula or relationship in terms of how the soil property is linked to their erodibility, and then use it in a model.
Thanks, Ali. Can you provide any comments on the use of coconut fiber blankets with plantings such as American beach grass?
I will pass it to Henry. I don't know about those stuff.
Henry.
Yeah, again, those sorts of protect the use of the fiber beach grass, the fiber matting is intended to maintain or enhance the longevity of the sand volume. The whole protection is under wave attack is really provided by a volume of sand. And the longer you can keep a high volume of sand at the toe of the dune, the better your protection is going to be. So to the extent that the matting enhances the longevity of that volume that you have there or accumulated there, it does provide protection. As I said before, the difficulty with those methods is that they're not very long lasting in terms of the strength or their ability to withstand strong waves. So when the strong waves come in, it starts to erode the sand away. And while the sand is still there, it provides protection. But after the storm subsides, you may have to replace all or some of that sand in order to regain that protection. If you have big rocks there, the rocks are stopping the wave from attacking the bluff. and by and large, they don't go away. So you don't have this problem of having to restore it. So either one will give you protection, but there are costs involved with both that have to be considered in terms of the benefits and the costs that you incur.
Thanks, Henry. Roy?
Yeah, first, Dave Park put in the chat box. There's a U.S. Army Corps of Engineers sediment budget tool, which has been really helpful for a lot of us in determining how much bluff material is approximately going into the lake in certain areas. So he put a link there in the chat box, and I encourage you all to check that out if you're curious. And I have a question with a few follow-up questions. The observations made in the wave tank model are a result of cohesion, vertical bluff, then undercut. If the bluff was taller, would the undercutting be less and the bluff be more sloping? So I'm guessing, is there a relationship between the height of the bluff and the angle of the bluff?
Well, that has to do with the stability. I mean, it's not related to erosion. So you're asking whether if the bluff is higher, it should have a slope. Is that what the question is? Or it should have a certain slope?
Yeah, I think if the bluff is taller, like if you change the vertical extent of the bluff, is the slope gonna maybe even out or balance in a different way?
Well, I mean, it has to do with the stability of the bluff. So if the bluff is high, depending on the material, it has a stable angle that try to reach that. And but again, if the question is whether the higher bluff are more exposed to erosion, it's a controversial, or there are different opinions on that. Some people believe that if the bluff is high, once it failed, it provides more sediment to the beach and keeps the beach balanced for a longer period of time and provide protection to the shoreline. Other people don't believe that. They feel like they explain that if the bluff is higher, it's going to be more likely to fail. And at the same time, if the bluff is high, once the bluff fails, typically around 45 degrees plus minus the angle of the internal frictional angle divided by 2, that's going to be the balanced angle. It's going to cause more setback of the edge of the bluff. So we haven't looked into that problem, but there is apparently some implication in terms of recession rate as a function of height of bluff. Yes.
Okay, that was one of the follow-up questions, was how the angle of internal friction plays into the model versus reality and versus cohesion. What is the balance between the strength and the water content? And can you comment on the applicability of the model and difference between the till and sand materials?
Yeah, so the water content, as I mentioned, those curves, if the water content is enough to provide more packing in the soil, which we call it optimum water content, that basically provides higher shear strength because the particles are more interlocked, so they cannot move more easily. So that has implication in terms of shear strength of the soil, and we demonstrate that via more column curve. What was the second part?
Can you comment on the applicability of the model and the difference between the till and the sand materials? Yeah,
the model right now, we haven't implicated or applied these formula into the model, but what we are trying to do right now is looking at the low fine content soil. But the goal of the project is to broaden this range and go to a higher rate of fine content, which takes us to more of clay sand rather than sandy clay. So it's kind of, we are right now at the low fine content rate in terms of soil composition, but part of the proposal was to look into the more cohesive till type of material, which we're going to take sample from the Great Lakes and do some experiment in the lab on those.
Kathleen?
Thanks. Okay, so Sarah, thanks for joining us. She would like to know, having researched base bluff removal, have you researched stormwater runoff and coastal erosion?
That's the runoff plays maybe two roles as much as maybe Henry can comment on it. One is the runoff itself creates some sort of erosion on the top layer. But the other issue is, they could add up to the water content and pore pressure. So once you increase the pore pressure of the water in the soil becomes loose, and they could be, erode. Or if it's a bluff, they could fail without even having wave impact. Just the stability of the slope is going to be undermined. So those are the different aspects of the runoff problem. We have not looked into it. We are planning to look into the effect of the precipitation, you may call it, or water content in terms of pore pressure in the soil. But we don't study the runoff in terms of the superficial shear stress and erosion of this top layer of the soil. That's not within the scope of this project.
In terms of the bluff face facing the open water, many people will see the runoff erosion. They live along the bluff will see the runoff erosion, the sand sliding down the bluff face in rainstorms. And that does occur, and it can be important. It's usually controlled by some sort of vegetation. But the runoff erosion becomes more important as time goes on an unprotected bluff face. And this leads to the development of those ravines that cut back into the inland. And those are not reached by waves, but erosion is still a significant loss. So it's a different mechanism. And it can be more important than the wave erosion once you get out of the reach of those waves in the first place.
Thanks, Henry. Ollie, here's a comment. Final analysis, bluff erosion is a result of wave energy being able to impact the base with sufficient energy to displace and remove material. Some form of energy dissipation mechanism would seem the best method or basis for reducing bluff erosion.
What methods? What methods would be the best to reduce the wave energy? Is that what the question is?
Some form of energy dissipation mechanism would seem the best method or basis for reducing bluff erosion.
Well, I think in general that's true. The bulkheads and revetments are the ultimate form of dissipating wave energy by just not moving. But in some places, and I think there's a small one on the Long Island coast, there had been put in offshore breakwater, which was intended to break waves before they reached the bluff. The installation was too small and now too old to be whether you can judge it effective or not. But certainly you could control erosion, in my opinion, to a large extent by controlling the wave attack. The building up of sand dunes is another way. There the wave energy is spent on moving the sand dune out of the way rather than getting into the bluff. So in general, any attempt to reduce that energy is going to be beneficial. A lot depends on how much it costs you, how often it has to be replaced, and these sorts of things.
That's right. To add to what Henry mentioned is offshore breakwaters are probably good for places such as Long Island Sound, where the waves are small and high frequency, because those are more effective for that kind of environment. If you build such a structure you see that in Caribbean, they build a lot of offshore breakwater because the waves are not that strong quickly. The beaches are very shallow. But if you build those kind of structure on, for instance, South Shore, and on top of it you have sea level rise, those structures become basically useless over time. The revetment and the breakwaters, those kind of structures work, pretty well in terms of dissipating wave energy. But the issue is that kind of approach should be done at the regional level. Again, if you just protect your own property with the rocks and the breakwater, over the course of time, if the neighboring land recess, those structures are going to be basically, you know, falling apart and dislodged. The rocks are going to be dislodged, and then after a while they're going to deteriorate. So they're good in a short run, but not in a long run. And it has to be done on a regional or community scale rather than just person level.
Thanks, Ali. I know we're coming down to only about 5 or 6 minutes left in our allotted time till 11:30. There are 3 more questions in the chat box. I'd like to try and get through all of them. I'm going to ask this, Ali, would you be able to stop screen sharing? I want to put up a slide with all of our contact information for people in case they need to run off at exactly 11:30. Thank you.
Sure.
So Matthew would like to know, how does your numerical model correlate with the Army Corps sediment budget tool? For the, and just as a follow-up for the person that asked the question, does, I guess this was a previous question, does the Army Corps tool include Eastern Lake, Ontario?
Well, the Army Corps tool, that was my question toward me, right? Is that...
Yes.
Okay. Yeah, the Army Corps tool is just a software, and what you have to do is you give it the shoreline profile, whatever it is. Doesn't matter whether it's you know, a particular location in Long Island or on West Coast, and then you provide it with the offshore wave and water level conditions. So that those information could come from buoys and gauges, you know, operated by NOAA, or through some regional numerical model, which are being done, you know, on a daily basis by NOAA and other government agencies. So it's a software that you could, you know, apply to anywhere, regardless of their geographical location. So, does that answer the question?
Thank you. Corey would has a comment question. He says the New York State DEC recommends the use of tackifier products when hydroseeding to protect exposed soils from erosion on construction sites. To your knowledge, has any tackifier materials been used on bluffs? It may be a temporary solution for those bluffs whose soils are highly erodible and likely more cost-effective than beach replenishment.
Yeah, I haven't heard of any of those being used on bluffs, but that doesn't mean they haven't been. Again, we're looking at the issue of the overland runoff and heavy rainfalls on unvegetated bluff sands moving down the bluff, and planting the bluff surface with plants that don't get too heavy. Planting the bluff surface can retard that kind of erosion, and I imagine the use of trafficker would help. Terracing is what's usually done in order to slow that down. It doesn't really help you from the waves attack, though. You can have a nice vegetated bluff surface where there's no sand being washed down the surface during rainstorms, and the water level gets elevated and the waves eat away at the bluffs, and then all of that is gone. I think one of Kathleen's slides showed the terracing kind of all broken apart. The overland runoff had been stopped, but the wave attack and undercutting had not. There was another question there about oyster castles and reef balls. Again, you could dissipate the wave energy by offshore reefs, which could be constructed from oyster castles and reef balls. The problem is getting it on a large enough scale in a right place to actually be effective. Ali pointed out the issue of having to deal with sea level rise. You also have to deal with, in some places, the submerged shoreline is fairly steep. So in order to get these things high enough to impact the waves, you got to be right close to the beach to begin with. So there are practical problems that have to be considered. Although in general, anything that's going to reduce wave attack is going to be helpful. The question is how much and how often is that to be replaced and how much does it cost?
That's right. Yeah, one of the things we are trying to explore is, again, it's not at the practical level yet, but we're trying to, with some students, trying to see how some bacteria could help protect the erosion of bluffs. These bacteria are not, they don't have any health issues. They're being used for different geotechnical solutions. What they do is they produce some sort of calcite, which kind of, it's a natural cementation process. And that kind of strengthens the soil from erosion. But the issue is, it solves only part of the problem. I could also add some issues, because if you have a lot of precipitation, by creating a cemented layer of bluff, you're basically, stopping those water from being irrigated from bluff, and they could build up a high pore pressure. Again, the different approach have their own benefits and basically problems. So yeah, because the problem is so complex. It's not, even the beach erosion, the sandy beach erosion is complex enough. Now you have to deal with the multi-hazard, because the stability of the bluff, a lot of geotechnical consideration to be considered for the bluff stability.
And we can't ignore the issue that was brought up earlier, that the erosion of the bluffs may be important for the supply of sand to the beach. How much of it has to be allowed to erode, where does that sand need to go, is a question, site-specific question. We certainly probably do not want to cement over the whole bluff face in order to protect us against erosion.
That's right. We are focusing more on the toe of the bluff, where we have the reach of the runoff, pretty much, to see how we can. I mean, again, this is more of a conceptual idea.
I'm learning how to use this chat room, Kathleen. I see Aaron's question about is the only alternative to do nothing. Well, if we're going to go in for big, heavy-duty offshore reefs and groin fields and things, I think it has to be regional, and it should be regional if that can be managed. But certainly the other alternative is not to do nothing. Depending on what the nature of the problem is, you can control overland runoff by planting the beach surface. You can control toe attack by armoring the toe of the dune. You do have to deal with these other issues as the impacts on neighboring properties. But there are things that can be done to address certain elements of the erosion problem and slow it down, or buy you a lot of time if you choose the right ones.
Thanks, Henry. I just want to interrupt real quickly, since we're 2 minutes over our stop time, and I think it's awesome that we still have over 50 participants still online with us. I'm happy to keep this webinar running and we can continue this discussion, but for those who have to run to their next Zoom meeting, I just want to remind everybody that the recording of this webinar workshop will be available at New York Sea Grant's website. Again, please take the 2 bluff erosion surveys, or take the one appropriate for your region of Long Island or Great Lakes. And there's also a link to a post-workshop survey. If you would, Roy has put it in the chat box. If you wouldn't mind taking that, we'd love to get your feedback. So that being said, you have all of the links. We can also make the PowerPoints available. And here, I'm going to leave it on this slide. Here's all of our contact information. Feel free to reach out to any of the 4 of us if you have any follow-up questions. That being said, we can go back to the chat and move on to the next question. I'm having a tough time pulling it up. Henry, can you read Laura's?
Yeah, the bacteria. I think that's the question, right? I would be interested in bacteria. That was.
Is that the bacterial build soil structure?
Yes, it's a emerging topic in geotechnical engineering and recently in coastal engineering. I can share some publications on that. And again, I'm still learning about it. It's not my expertise, but these kind of problem kind of motivated me to look into alternative solutions. If you search for on Google, I think it's called soil bacteria and soil mitigation and the geotechnical engineering, that kind of keywords, you will see a lot of publication recently over the past maybe 6, 7, 8 years published.
Thanks. Roy, can you check the chat? My computer is not letting me pull it up.
So there may have been one I may have missed. I'm trying to find it from Laura about was the oyster reef one
Yes, yeah.
fielded? Okay. If that's the case, then I think we are up to date with the questions. So, I mean, it's still open. So I think if we want to stick around for 5-10 more minutes, then, Henry and Ali are still here.
Yes. I'll be available until 12. So let's move on, continue.
Okay, we just got one more. What is the ecological impact of either bluff loss through natural erosion, if there is one, or through the response in the form of bluff armoring like we saw in the video?
Henry, do you want to? Or you just muted yourself, I think.
I find pushing these buttons exhausting. I never know what I'm doing half the time. Well, there are gonna be ecological impacts. It's more a question of habitat, I think, than direct impacts on species. So if you don't protect the bluffs, you're getting sand delivered to the beach. The sand itself can become a problem in terms of when it reaches low-lying areas like salt marshes. You know, in some places around here, we've had problems where there's been overwash from the beaches that have been burying the salt marsh, and you can envision that excess sand has been inimical to the marsh development. So that you can envision those kinds of issues. Again, it depends a lot on the site and a lot on what habitats are available and what the sand flow is. On the other hand, if you don't do bluff protection, you get eventually the creation of ravines and valleys cut back into the bluff surface that provide a different sort of habitat. They remove some of the tableland habitat, replace it by this valley ravine type habitat. And is that good or bad? It's different. There are changes in habitat that are caused by the erosion or non-erosion of the bluffs. What the quality of those are and which are more desirable, that's a question I can't answer. I think habitat value and the goods and services provided by different habitats is a knotty issue and one that's continuing being evaluated. But it is an issue, and I think in looking at the cost and benefits of protecting bluffs against erosion, that's one of the issues. It doesn't necessarily is automatically the overriding issue, but just like the sand sources, it's one of the things that should be considered whether or not it can be definitively answered.
That's right. One thing I need to add is, you guys saw the video I showed. I mean, the water, we started with the clean, fresh water. And then after 5 minutes, the water was all muddy. So it definitely adds to the turbidity of the water. And there are some, I saw a couple of papers on the Bluff erosion impact in terms of turbidity and some species in Black Sea region. And they reported some species have been impacted significantly by the added turbidity of water due to the bluff recession. Because in Black Sea also, bluffs are more like a glacier clay till type of material, which has a lot of fine content, and they're not going to settle quickly. They're going to be suspended for a long period of time.
Thank you. Alan put a peer-reviewed journal article in the chat box about the biocementation by microbially induced calcite precipitation, soil stabilization. So if anybody would like to check that out.
Yes, thank you. Yeah, but they call it biocementation. That's, that I was thinking about what word it was now, yeah.
And other than that, looks like we haven't had any questions come through. So again, I'll mention, feel free if anything comes up after we finish, feel free to send it to Roy or myself or Henry. And thank you again, everybody, for one more question. Is there one type of stabilization for the toe of a bluff that is more preferred than others?
Not really. I mean, I don't believe there is a one size fit all. So it depends on the beach and the wave climate. I mean, I mentioned about living shoreline that I didn't believe it's a good solution, but it apparently it's a solution for a low energy wave climate, such as some places in Great Lakes. So yeah, I mean, you can think of different solutions, but again, you need to look at a broader issue in terms of wave climate, soil, and other aspects. So no, there is no one particular solution works for everywhere. Henry, you're muted.
You muted yourself.
It kind of depends on what you're trying to solve. If you're only worried about undercutting and claps, boy, for my money, you can't beat big rocks. But if you also have to worry about overland runoff and the supply of sand to the beach and changes in habitat, then you have to look at these other alternatives and may have to substitute longevity of one approach for flexibility in the other approaches that allow you to provide habitat, to provide sand to the beach at the same time. Even though the issues appear to be the same, there is this element of uniqueness to almost every one of these erosion problems.
Yeah, exactly. I'm actually teaching coastal engineering, and the first session, what they say is, there's no design code in coastal engineering. So every project is very unique and specific to the site, and it may or may not work for other places. So everything has to be designed uniquely for that particular place and with the particular climate and environment, basically.
Thanks, Ali and Henry. And Glenn just followed that up with a quick comment that the New York State DEC is starting to limit the size of the rocks you can use at the toe.
So, okay. Well, so the rocks are allowed based on probably some criteria. I don't exactly know what dictates the rock size, but I don't know. Henry, do you know about this? I've never heard of it.
He mentions that he believes it's 1.5 ton.
No, I think there are, I don't know what the limits are, but I know there are limits to what you can do. And again, I think that's an approach to try to provide some flexibility and for the condition, you know, what if you do have to remove it or replace it somehow? You don't want anything that's necessarily too permanent. We don't see seawalls, you know, we don't, Galveston, oh Galveston, we don't see concrete seawalls at the toe exactly for that reason.
Laura mentioned that the rocks are limited to 2.5 tons and less than 8 feet wide.
That's for North Shore, right?
Yes.
Okay.
Yeah.
Yeah, probably you don't need larger than that because the waves are not going to be that big on North Shore.
Yeah, and she also goes to mention that certain villages and jurisdictions have their own restrictions or limitations.
Yeah, I mean, people may want to be more like super conservative, but again, if you want to dissipate the wave energy, first of all, the waves are different in different locations. North Shore, probably the waves cannot be too large compared to the South Shore. And the other thing is it has more to do with the number of layers of the soil than the size, because the energy is more being dissipated to the, you know, through the porosity of the rock layer than the size of the rock layer. So maybe putting 3 layers of 1 ton rocks better than 1 layer of 2 tons. Right, so.
And I'm going to end it at this one last question. Is there any reasoning for the limits of both the rocks and bulkheading? So, you know, the DEC limit of bulkheading is an elevation of 13 feet. Do you know if there's a reasoning behind it?
I feel like it has to do with the kind of putting a cap, because people shouldn't be too or very over conservative, because I mean 2.5 tons should be enough in terms of wave energy dissipation. And probably, as Henry mentioned, it might have to do with, you know, with the mobility, how to handle those rocks if you have to remove them. It's probably easier to remove a 1 ton rock than 5 ton rock, I guess. Anyway.
I'm not privy to the DEC's reasoning on this, but it would seem like a wise thing to do, because you want to provide some flexibility to deal with changing conditions. You don't want to lock yourself into something that is permanent for all time. Of course, you can't do that. But I think going into these sorts of shore protection, everyone realizes there's a great deal of uncertainty in both the performance and in the future conditions. So to provide some room for adaptive management is a wise approach.
Sure.
All right. Well, thank you, Ali and Henry, for all of your information. Thank you, Roy, for your assistance, and thank you to everybody who's still on the line. Really appreciate this. We had a really great discussion and some really great feedback.
Thank you, everybody, for attending our talk, and please reach out if you have any additional question, and or you know, we can help.
Thank you, and look out for an email coming your way, again, with all of the resources that we've provided today.
Thank you, Kathleen and Roy and Henry. All right, have a good day. Bye-bye.